Okay, so today is day 2 of logs, and we are just remembering something about how to rewrite this as a log. That is log base 2, because that's the base, right? And then you go to the other side of 18, and you come back here, equals x. Then I challenged the kids to remember how we had put those in the calculator on our first day, just to see how the decimals worked. It was log 18 over log 2. Now, one of the things, if you just type that in, you don't really think about it. Do you get that these don't have bases on them? What? Oh, the other one had a base on it. The other one had a base too. This one doesn't have a base. If it doesn't have a base, then there is a base. And it's the most common base. It defaults you to base what? Base 1's a good guess, but that's not it. Base 10. It defaults you to base 10. If you just type in log 18 on your calculator, which I think is what most of you did to check your answer here, you are typing log 18, but you mean log base 10 of 18. So the log that doesn't have a base has a base, and it's base 10. All right, so notice this is changing me from log base 2 of 18 to, again, I don't have to say these, log 18 over log 2. But if I don't say a base, it means the base is 10. Here's the really weird part. Because this is a ratio, and I know this might be too early for you to understand this, but that base can be any base you want. The calculator can only do base 10. But if you had a calculator that would do base 7, this could be log base 7. Because that means my numbers would just be a little bit either bigger or smaller, but proportionally so. Let's say that base 7s are all a little bit bigger than base 10s are. Then your answer is a little bit bigger on the top and a little bit bigger on the bottom. When you actually divide it out, it comes out the same. So this is complicated, but if I have a 5 to the x equals 20, tell me, this part's easy. What's the log for this? Say it, log base 5 of 20. And I could say equals x. Then it would be log 20 over log 5. But that's because you're using a calculator that's base 10. What if your calculator was in base 42? It would still be log 20 over log 5. It would just be log base 42. So you could use any base you want. It just happens to be that your calculator likes base 10. Why? Because it's the most common of all the logs. So if you ever just see one that doesn't have a base, log 9, you might be like, Mr. Server, it doesn't say what base it is. By not saying what base it is, it's saying what base it is. What base it is. Base 10. All right. Now there's one other base that you can use that gets used a lot. It gets used so much that your calculator has a special button for it. Anybody know what it is? It's 2 letters. See if anybody can find it. LN, that's it. LN9 is a typical problem as we get to the more advanced problems. Notice, again, it doesn't have a base. But this is a special base. It's log natural is what that LN is standing for. Okay, it doesn't mean that it's like herbal or that it's like organic, like those crackers certainly are. At least whole grain. All right, anyway, LN means log base E. Log base E. Everything has to have a base. It's just if it's not saying the base, then it's something special. 9 times out of 10, your homework is going to say the base today. But if it doesn't say the base, it's kind of part of the question. And if it's like this, that means log base E of 12. Now, I know I told you what E was the other day, but I know you might have forgotten. E is 2.718, and it's like pi. It goes on forever. Want to see it on your calculator? It's right above the, I think it's the divide key. Right, go above the divide key and just hit that E and make it show up on your calculator and hit enter. Go second divide key and hit enter. See how it says 2.7182, blah, 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 blah. Okay, so if you have a ln, that means that it's really a log base E. If you don't have a base, but it says log, then that means log base 10. This uses the log key on the calculator. This kind uses the ln on your calculator. Okay, so now, what do we really need to understand for today? Say you were given this. I am cruel enough to expect you to do that without a calculator. There's a with calculator part of this test, and there's a no calculator part of this test. And I believe if I'm wrong, then there's only a no calculator part, because I know there's problems where you can't have a calc. Okay? So how would you be expected to do this on a test? There's two ways. If you don't have a calculator, you're going to just, well, if you had a calculator, you type log 8 divided by log 2. Okay, but you don't. Whoa, can you shut that door for us, please? Maybe I. Thank you very much. All right. So if I say equals x, then I can rewrite this thing. And if I rewrite it, you all should be good at this by now. It's 2 to the x equals 8. This is the slow way of doing it. Who wrote on Walden Pond? No English scholars in here? All right. Well, he enjoyed taking the walk that was kind of the long way, and taking time to smell the roses and all that kind of thing. If you like that way, this is a good way. It got lots of roses. It's slow. Takes plenty of time. But if you like the shortcut, which many of us like to get our homework over with quickly and move on to the next thing. If you like to go fast, I'm going to show you the shortcut. But if I was going to do this the long way, I would continue by first rewriting it and then making them have the same base. 2 to the x equals, oh yeah, that can be 2 to the third. And then I'll say, oh, wait a minute, so therefore the bases are the same, and therefore x must equal 3. And that took me a whole bunch of steps. If I had gone to this problem and then just said, you know, 8 is the same as 2 to the third, the answer is 3. That's a lot quicker, isn't it? Why should it work? Because the base of my log is the same as the base of my little exponent. Do you get how the bases are the same? Do you remember that theme? If the bases are the same, see it down here. If the bases are the same, it's kind of like that. So see if you can do the fast way. Log base 2 of, let me say, 16. You could say equals x, rewrite it, yada, 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 but what's the fast way? Replace 16 with what? 2 to the fourth. Instant answer is what? 4. Now, there are some times that speed is good. One of them is the ACT. And logs is something that can be on the ACT, basic logs, like we're doing right now. You might be notching in one more thing that you could get credit for on the ACT. And if you know this shortcut, boom, answer's 4. And you don't need to do anything more. Now, if you needed the long cut, and calculator has allowed on the ACT, we could have just made this into, let me think, log 16 divided by log 2 equals. Yeah, that would have worked. But on the ACT, they're probably going to make it a little more challenging and throw in something where there's a variable in here. And that means the calculator wouldn't work, because they don't want you to just use the calculator for everything. They want you to know how the math works. So what if I made it this? You get how you couldn't put that in the calculator? But if you understand what I was just telling you 2 seconds ago, what's the answer? M. The answer is M, or x equals M, yes. But the answer is just M, because the bases are the same. That's the answer. All right, so they make the base the same as the other number, except you got to tweak it. Like, let's say it's this, the third root of 4. How could that be a 2? Well, everybody try to write this as a 2 to a fraction power. Once you've got that, you'll have the answer. It'll be the fraction. So That's 2 to the something. Could you get that door? Unfortunately, kick the kickstand down. And thank you. That's 2 to the fraction exponent. Here's what I would like to do. I would say that this 4, oh, that's not good. It lost its little, I'll fix that. Okay. Would you agree that 4 is the same as 2 squared? So now do you see that this is log base 2 of 2 to the fraction power? Remember me saying roots go on the bottom? 2/3. And if I made my base of my log and the base of my exponent the same, then the answer is the exponent. And again, if you want proof, if that doesn't make sense to you, that this should be the answer, let me prove it to you. Do you get when there's no x in the equation, I can say equals x? Then I can rewrite it. 2 to the power of x is equal to 2 to the 2/3. And now look, the bases are the same, so the exponents have to be equal. X must be 2/3. And it's just a lot simpler to go, oh, it's 2/3. Okay, let me give you another one like that. Log base 3 of the 4th root of 27. I'll pause for a second. You can either do it the long way or the short way, and I'm fine with either one. The long way would say equals x, and then involves getting the bases the same, and it would take more time. But it's okay. I'll pause for a moment. Okay, so did you say that this was log base 3 of 3 to the something? Well, how do you get a 3 to turn into a 27? Yes, sir. Yeah, so it's like this is 3 to the 3rd, and then that helps me write this as 3 to the what? 3/4. And therefore the answer is 3/4. How many of you would have had that one right? All right. Here's another one that's still trickier, just because it's got a variable. But you can see that the bases are going to be easy to make the same. Would you turn it my way, and I'll tell you if you did it right. That's it. You got it. That's the one. 3 people have it so far. 4 people down out of about 25. Can't read it as a fraction? Yes, that's it. 5 people, 6 people, 7 people, 8 people, 9 people, 10 people, 11 people are right. 12. I can't read it. 13, 14. Not it, but thank you for trying. 15 are right. Got to zoom in and make your screen brighter. Yes. 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 Okay. Do you get that this is a to the roots go on the bottom, and the other must be a 3, so there we go. 3/2. And therefore the answer is 3/2. Okay. You got about half of what you need to know already. In fact, you've got at least 3/4 of the worksheet already figured out for today. 3/4 of the worksheets is those two things. Let me go back to the one we started earlier in the hour. If I said 5 to the x equals 19, you should be able to say, okay, what log is that? And then what's it close to? Without a calculator, I'm thinking it's like what? 2.7? No, it's a pretty bad guess. Take a guess. About what is it? And if you're getting even close, then you know it's between what 2 whole numbers? Between 1 and 2. Do you agree 5 to the 1 is way too small? 5 to the 2nd is actually a little closer, but it's too big. So then it's closer to that one, though. So I'm going to go with like 1.7. And then the last part of that is, how do you actually get it? Log base 5 of what? 19 equals x. And then you go log 19 divided by log 5. And what was it? I guess 1.7. What was it? 1.83. I'm only off by 1/10. That's not bad. Really. Because if all you have to do is be able to say it's between 1 and 2, between 5 and 7. If between 5 and 6. Sorry, you have to get it down to between two whole numbers that are right next to each other. All right, so here's one like that. It's a little tougher. 8 to the I don't know what equals 63. I'd like you to figure out the log for it. Take an estimate and say, I think it's about 1.9 or something like that. And then figure out what the actual answer is with the calculator. Did you get log base 8 of 63? Do you know how to put that in the calc? Log 63, which, by the way, you got to end the parentheses on that, divided by log 8. All right. And then the calculator would tell you the answer, but I'm going to guess it. Log 8 to the second is 64, so it's really close to 2, but it's a little less than 2. I'm going to go with 1.9 something. Would you actually use a calculator? What was it? 1.99. Ooh, that was actually, probably should have gone even higher than 1.9. You see how you can get really accurate pretty much in your head? All right. So, not super accurate, but I mean within a tenth. Okay. So last thing, there's a few more weird things that can happen with logs. And I want to give you like a little moral of the story kind of thing. This one is weird. But the answer in this kind of a problem is always 0. I want you to think about it. If I don't say equals anything, what should I say it equals? Equals x. And then would you please do a quick rewrite? And it becomes what to the what equals what? 2 to the x equals. Now think about that. 2 to what power would equal 1? 0 power. Moral of the story is that the answer is 0. And do you remember that's called the base? Do you remember what that's called? The argument. So I'm going to tell you something. If you've won the argument, you get nothing. Think about it. There's a 1 in the argument spot, and you get nothing. And math is telling you something there. Because if you and your friend are arguing over something stupid like pepperoni's better. No, sausage is definitely better than pepperoni. And you're arguing over something stupid, and you end up arguing about this and actually getting mad at each other over something stupid, and you win the argument. So who cares? Now you've like maybe lost your friend because you were arguing over something stupid. And that happens. It does. Even if it's not necessarily amongst friends, it happens amongst spouses. They'll argue about just stupid things. But it's really, the argument's usually about something else. But if you're arguing about some stupid thing and you just beat the other person into submission with your argument, then they're like, okay, fine, you're right, but I hate you. And it's not worth it. You've got nothing out of it. So, moral of the story, if I show you this problem, log base m of 1, what's the answer? 0, because it doesn't matter what m is. Anything with a 1 right there has to equal 0. It's a definition thing. Think about it. If I put, I don't know what it is, m to the x has to equal 1, that would have to be 0. Okay, so another little property that's kind of cool is this one. I know the answer already. Anyone want to take a shot at it? All right, I'm going to give you a hint by showing you this. The bases are the same. When the bases are the same, the answer is already there, and the answer in this case is what? 12. The bases are the same. That's a base with this exponent on it. That's a base of the log. The bases are the same. Therefore, what do you think the answer is? 12. One more thing. Would you agree that if it doesn't have an x in it, I can say equals x? And then I could do a rewrite. This one's weird because you think it's already a log, but it's not. It's an exponential. It's something to an exponent. So to rewrite it, you rewrite it as a log. And I know this is going to go over some of your heads, but some of you will enjoy it. Log base, what's the base of this thing? 3. And then you've got to jump to the other side. Remember, it never goes right in a row. That'd be too simple. Jumps to the other side. Log base 3 of x is equal to all that. Log base 3 of 12. And now do you see that that's the same as that? And therefore, x must be 12. That's the long, slow way of getting to the answer. But I'm trying to focus on giving you some quick ways. The bases are the same. The answer's already there. It's 12. All right. Toss some water on them. Ah, there we go. With me. Okay, good. That usually sparks enough fear and that they'll stay awake for at least another couple minutes. All right. We were thinking deeply. All right, good. So how about if we had 5 to the 2.8 equals x? What if I don't know like how to solve this? Well, then you're kind of missing the point. And sometimes people get so wrapped up in their logs, they'll try to rewrite this as a log. Why is that a dumb idea to try to solve it by writing it as a log? Yeah, because it's already solved. X is already alone. Why would I want to mix this up into a log, which would become that? It's not like it's wrong, but it doesn't help. It's already solved. There's your answer. You just have to use a calculator, 5 to the 2.8. So I'm just trying to say not everything needs a log, but do you remember? If the x is in the what? Exponent. If the x is in the exponent, that's when you have to have a log. So if it's like 3 to the x equals 29, that's when you need a log. And if I needed an estimate, I'd say it's about what? Not quite that big. 3 to the what is 20? It's okay. 3 to the what? 3 point something-ish. Okay. 3 to the third is 27. So a little bit more than that. So like 3.1 is my guess. But if I needed it exactly, I'd go log base 3 of 29 equals x. And I go log 29 over log 3. And there's my rewritten. And ooh, the cool thing about that is I just changed its base from base 3. Sorry, yeah, right here. It's from base 3 to these guys are in base 10, whether you know it or not. Because if you don't say the base on them, the base is 10. Okay, so I think we're close to ready to start the homework. I just need to stretch your mind with a little bit more. If I had this log base 3 of x to the third, do you agree x to the third means the exact same thing as this? It does, you know, that's what x to the third is. Then here's the kind of thing that's kind of cool about logs is that you can rewrite a multiply question like this as 3 separate logs. Log base 3 of x plus log base 3 of x plus log base 3 of x. If they're all identical to each other, it's kind of like saying a plus a plus a, which means that you could say there's 3 a's, right? You get this means, since there's 3 exact same thing, that I could say 3 times log base 3 of x. All right. Now, that was the long cut. Watch the short cut. That could have just gone right down there. Boom. And those are equal to each other. That's called the power rule in logs. I'll show you another one. Log base 5 of 2. No, I'm going to make this even cooler. 5 to the third. Do you remember how the answer is 3? Because the bases are the same? Watch what happens when I put this 3 down in front. Now it's 3 log base 5 of 5. But what's log base 5 of 5? 1. So it's 3 times 1, so it's 3. To get how these powers can come and drop down in front, I've given you proof twice now. So let me give you one more. Log base 9 of 8 to the second. Do you get how I could drop that 2 down in front and just say it's that? All right, this gets a little more intense. What's the 8 the same as? 2 to the 3rd. Now, can I drop that 3 down in the front with the other one? 6 log base 9 of 2. All right, didn't need to know that last stuff very much, but I wanted to give you just a taste of it because what's coming will involve that kind of stuff. All right, so at the risk of confusing you further, I'm going to stop there and get into the homework for today. So everybody, I'm going to pause for a second while we find this, find the worksheet for day 2. Okay, I'm going to skip problem 1 just for now because it's a pain in the butt. But I'm going to get right to problem 2, part A, which for those of you following along at home is this problem right here. Log base 3 of 3 to the 5 6. Do you get that the bases are the same? So what's the answer? 5 6. That's it. Done. It's as easy as you think. No calc, notice. No calc, no calc. All right. Next one. Bases are the same. Are they all this easy? Am I just going to write down the exponent every time? No. It gets harder. Negative 0.23. Okay, the next one. Wait a minute. They're not the same. Exactly. So how can you get this to just flip? You can't just flip it. You can put it to the -1 power, and when you do that, it'll flip, and then the base is the same, and then the answer is the exponent, right? So what do I do to those two? Multiply them, and what is -1 times negative 0.23? Positive 0.23. You're multiplying them. You're not adding them or subtracting them. You're multiplying them. And -1 times something just takes the negative off. In this case, we already had a negative, so negative times negative makes positive 0.23. All right. Do you remember me saying if you won the argument, you get nothing? This is another good example of that. Think about it for a second. Do you get that 7 to the 0 is equal to 1? And that means there's a 1 in the argument spot, and the answer should be 0. But this is another way to prove that the answer is 0, because if the bases are the same, the answer is the exponent, which is 0. So I can get the answer 2 different ways, and it's 0. The next one's a little freakier, though, because then the bases aren't the same. But there's a 1 in the argument. If you won the argument, you get what? Nothing. 0 is the answer. Because there's a 1 in the argument spot. Automatic. Now, I want you to, if you're ever stuck on something like this and you want to work it all the way out, remember the slow way works. 7 to the 0 is 1. So then this is equal to x, and then I solve it. 8 to the x equals 1. And then you just got to puzzle and go, 8 to the what equals 1? Oh, yeah, 8 to the 0 is 1, and that's how the answer is 0, the slow way. I'm trying to get you to be faster, though. All right. I know it doesn't seem possible, but that could have the same base as this, and it doesn't need to, because what's 9 over 9? 1, and isn't there just a 1 in the argument? All right, good. Okay, so your assignment is this worksheet all. They're so quick and easy, you probably finish in class, so no need to cut it down. I'm going to show you one of the last kind. This kind, sometimes people don't understand the directions. Once you do, they're not hard. It's saying this is between what and what. I like to rewrite them. Like this one, I would say 4, wait a minute, equals x. 4 to the x equals 5. And then I say to myself, 4 to the 1. A little too small, but close. So it's like 1 point something. So that means it's between 1 and 2. There. Can I just stop there? No. You have to rewrite it as a base 10. That means it's like just like they had said for this part, how do I put it in the calculator? Because that's what calculators do, is base 10. How would I put this in the calculator? Come on, how would you type that in the calculator? Log 5 over log 4. Then you have made it base 10. Because if you don't say the bases, they're 10s. And then it says value. The only way you're going to get that is with the calculator. That's why this part of the directions don't say no calc. So you can actually get the calc and go log 5 divided by log 4 equals. And let's just do one of those because some kids don't know where to put the end parentheses on that first log. They just type log 5 divide log 4, and it'll actually be wrong then. You need log 5 end parentheses log 4, and then what did you get, Mr. W? Did you do this first one? It's all right, I'll come back to you. I know you were rubbing your eyes. Look tired. How about you, Miss M? 1.161. That sounds very believable. Can anybody verify that? Yes, a lot of people are. It must be right. Okay, good. Good question. Oh, it does say to the nearest hundredth, which is 2 decimal places, so I really should go. It's almost like you cut it off right there, but then you just check and make sure that that last number past the line isn't 5 or bigger, and it's not, so I can just stop right there. If that had been a 5 past the line, then I would have rounded that up to 17 instead of 16, but it was small enough to leave alone. Just a quick rounding lesson there. Okay, that's all I've got for you for today. Okay.